Yeah. How's it going, everyone? All right. That's enough of that. All right. You fired up? Fired up for distance learning? I know I am. Okay. Yeah. Sorry, I was just making sure. I was just looking, monitoring things, making sure things are good to go. I know, right? We're pumped up. Again, I do need to make sure. First time I had moved my computer over to a new area, so I want to make sure everything sounds okay, looks okay, everyone can see everything, and then we will, do some actual reviewing for this quiz. So everything's good, sounds good, looks good. All right, I guess we should get some of that. Why did I just touch my face? So, okay, as far as the quiz, right? So it is just a quiz. It's chapter 10 quiz. It's on 10.1, 10.3, 10.4, 10.5, and then partial 10.8. Basically, surface area, and then 10.1 and 10.3, which involves like what the shapes are and stuff. Okay, so just to give you a recap of what's coming up, or a preview of what's coming up today. I'll do a sort of a 45, however long it takes to do the review. Then I will, and that's at 12. Mr. Greenhut's holding a Zoom, just sort of if you have any other questions, like specific questions, sort of an extra help type thing at 4. And then, let's see. And then tomorrow, almost the same thing. So the only difference is that the time that I'll be doing this, I think it's 1 instead of noon. So it's close, but it's around again, I think it's already posted, so you can check it out. And then Mr. Greenhut's doing the review around, or actually at 4 as well, for sort of Zoom question and answer. Tomorrow mine might be a Zoom as well. I'm not really sure, but we'll see how it goes. And then the quiz on Wednesday. You'll have Wednesday to do it, right? You can pick you can pick when you're going to do it, but it's going to be timed. So, yeah. That's for Chris, the message on the screen. Anyway, so the quiz. So if you have any time on Wednesday to do it, it's going to be via Schoology. You'll do it. You'll go through it. You'll submit your answers. Then you're also going to have to submit your work, right? So there's sort of going to be like 2 places to submit. So, I think that's good. All right, so let's jump into the review. Yeah, let's talk about it. Let's let's do this thing. So I tried to put some problems together, just going through at least what the topics are, to review what the topics are. Again, of course, the best thing to do would be to go through your homework packet. There is if I can pull that up here, there is actually that's our homework packet, but there's let's see, it's kind of zoomed in now. Let's go. Okay, so there's this review, which sort of covers the sphere and hemisphere, surface area of compound shapes, of prisms, and there's some pyramids and cones down here as well. Prisms, pyramids, and cones. So again, pretty good review to look at as well. Again, all the answers of those are posted, so you can check those out. Quick, let's just do a quick attendance just to make sure we're all here. Chris is here. Ari's here.
Bueller.
He's sick. My best friend's sister's boyfriend's brother's girlfriend heard from this guy who knows this kid is going with the girl who saw Ferris pass out at 31 Flavors last night. I guess it's pretty serious.
All right. I'm just getting my soundboard worked out. But basically, you can check that out. Anyway, so back to what we were doing here. Okay, so the yeah, we're going to be going through the formulas again. That's part of the review right now. I'm gonna run through again. People seem to forget sometimes that we did this whole thing at the beginning about what a face and edge vertex were. We had Euler's formula. We had something where it was like, hey, here, given the polyhedron give the polyhedron name for these things. So like what a prism is, what a pyramid is, how many bases they have, stuff like that. And so we can look at those, right? So for instance, like give the polyhedron name. Remember, we name a polyhedron using its number of faces. So like a dodecagonal prism is going to have a base of 12 plus 2 dodecagons for bases, right? So it's polyhedron name. Man, I should have gone the other way with that. This is good. We can change this. We have the technology. In other words, if they're there you go. It's a decagonal or decagonal prism. Basically, there's decagons, 10 sides for each of their faces, plus 2 bases, means that this would be a dodecahedron, right? Remember, we name it a hedron on the end. So like this one right here would be a dodecahedron. And then like if it's a heptagonal pyramid, well, we know the pyramid has one base, so it's a heptagon. Is the shape of its base, which means it's going to have 7 sides, which means it's going to have 7 lateral faces. If it has 7 lateral faces, plus the one base for the pyramid, there's going to be 8 faces total. If there's 8 faces, that's an octahedron. So we sort of want to make sure we could do those things, and it also go in reverse. So if I gave you if I said, all right, you know what? If there is let's do another page here. If I was like, all right, well, if you have a nonahedron. Let's just actually do octahedron. If you were given an octahedron here, right? And I said, well, what prism would that be? If I had a prism that wasn't an octahedron, well, you would say, all right, well, like this right here means 8 faces. And if it was a prism, right, we know that 2 of those faces are bases. So 2 of those 8, which means there are 6 lateral faces, which means there has to be 6 sides for each of the bases. In other words, we sort of take the 8, we subtract 2, and we get 6. So this is going to be a hexagonal prism, right? Because there are 8 faces. 2 of them, because it's a prism, 2 of them are bases. And if 2 of them are bases, that leaves 6 lateral faces. All right? And then the same thing if we were naming this as a pyramid. Well, it still has 8 faces, but in the case of a pyramid, if the octahedron was a pyramid, we'd have one of the bases would be, we'd have one base. One of those 8 faces would be a base, and then from there you can subtract 1 and get from the octa and get hept, right? So there are 7 lateral faces in our pyramid, so it would be a heptagonal pyramid. So just keep those in mind. Now we're going to get sort of again, that's just a reminder. You should look through those worksheets, all that good stuff. I just want to give you, no, it's over here. But just going to give you a sort of a rundown, like all these types of problems that we did on your homework. They're there. The reviews are up, the keys are up, and all that good stuff. So you can definitely check those out. And again, make sure Euler's formula. If you can solve for the number of faces, then of course name it based on its faces, stuff like that. Okay. Yeah. All right, so if we actually look at some of these formulas, right, we should have an idea what a prism and a cylinder and then a pyramid and cones are. So as far as the formulas go, let's just write those out, right? Let's just write out what the formulas would be for these things. All right, so if I have a prism, and again, we're talking about surface area for this whole thing, so it's the surface area of a prism. I'm going to start everything with SA, right? So as far as prism goes, we are talking about surface area, so we know that the surface area of a prism, and again, we talked about in class already why. This is a review, so we talked about the like how this came to be. Sorry, I was reading some of the comments, but we talked about like how this is going to how we develop this formula. But for now, we should know what it is, right? So it's pH plus 2b. And again, we should know that this is the perimeter. The P stands for perimeter of the base. Again, the base is a shape, it changes. We should know that the height is the height of the actual prism. And again, the height of the prism is the distance from each base. So if I had something that was just like a, I don't know, triangular prism here, right, and I had, okay, not bad. So if I had a triangular prism, right, we would know that the triangles would be our bases here. So like that's a base and that's a base, and they're both triangles. And so the perimeter of the base would be the perimeter of one of those triangles, of one of the two bases, right? The height of the prism is the distance from base to base, so that would be like that right there. Okay, so keep that in mind. All right, and then we would know that big B here stands for the area of the base. And again, these bases are going to change depending on what type of prism it is. In this case, it's a triangle, so 1/2 base times height works for that triangle. Really, I mean, if it was a trapezoidal prism, we'd use our area of a trapezoid formula. If it were like an octagonal, you know, prism, we'd use the area of an octagon, a regular octagon most likely. So we'd use 1/2 AP. So we just use it based on this. All right. Let's see. Yeah, let's see. All right. So that's good for prism. And let's just sort of do the similar thing, but for cylinder. And again, I told my class, again, I don't know how Mr. Greenhut did it, but I told my class, as far as remembering formulas go, I said use the same formula for prism and cylinder, because they are the same formula. It's just more specific because there's only one base. It's a circle. But we can look at that. And again, of course, we should know a cylinder is just a sort of a circular prism, essentially, where the bases are circles. Right? So this is a cylinder, but basically I'm still using this. I can still almost use the same formula. And I say almost, I mean, I definitely can. The only difference is that this perimeter is really circumference, right? Because there's no perimeter of a base. The base is a circle. There's no perimeter of a circle. There's a circumference of a circle. So we can sort of think about it as 2 pi r. The height is the same thing. The base is still the area of the base, except we know what the base is. It's only one formula involved. So we could plug these things in and come up with our own formula. I still say to use the same thing, right? This would still be the height. Like the area of this would be the area of the base. The circumference, right, would be, can I sort of say the circumference is sort of the, circumference of one of the bases is the perimeter of the base. So they are the same thing. So again, I'm looking at them in terms of prism and cylinder are the same formulas. That's really what I'm looking at. Make sense? Yeah? Wow. I know, right? I'm getting more sound effects, don't worry. But here they are. They're coming. I don't know. I put some of them on here, and I don't know what they actually are doing. So, yeah, okay. We'll worry about it. We'll work on that. All right. So that was essentially all of 10.4 that I just did right there. Yes, it comes down to a formula. Now, how you're using it, making sure finding the area of the base can be a long problem, especially if you're talking about a regular polygon or something where you're doing trig or figuring out the height using Pythagorean theorem. There's a lot of things that can happen that can go into this, but so that comes down to sort of practicing and making sure we got them. And we'll do some of those problems, but that's the general idea right there. Let's see. I mean, all right, let's look here. Let's just do the next. So the next formula are pyramids, and of course we'll lump cones in there as well. But if I'm trying to find the surface area of a pyramid, again, we looked at how to find that, but essentially the surface area is going to be 1/2 PL plus B. Right? And again, we can sort of take a closer look at what each of these things are. Again, P, stands for the perimeter of the base, like it did before. And A, or B, I should say, is the area of the base, like it was before. I'll still write it in, because why not? All right, the only thing that's unique about this is the L, lateral height, which is slant height. That's what it stands for. And it's the slant height of our pyramid. So if I was drawing a pyramid here, it could be any type of pyramid. Let's just, can I draw a shape here? Let's take a, let's do this. Is this going to work? Okay, cool. So if I just take this hexagon and make a pyramid out of it. Okay, so I have a hexagonal pyramid there, right? It's got one base. The slant height, remember, is the lateral height. It's the height of one of the lateral faces. And the lateral faces are triangles, so it's the height of the triangle. It would be the equivalent of like this in here that forms a right angle. It's the height of that triangle. Or, you know, it's this right here, or this right here. It's the height of any one of them. They're all going to be the same in the case of a regular pyramid that we got going on here, but that's what our slant height is going to be, right? It's going to be one of these reds. So each of those are going to be, you know, L. And again, the actual height of the pyramid, right? If I was sort of looking at that, is the distance from here to sort of the center here. And so like that is the actual height. Sometimes you might need the height to find the slant height. Pythagorean theorem happens, right? And so, yeah, basically we can find out all the stuff that we need from there. Again, it's more of a process than just plugging in 3 numbers. We got to find those numbers, deal with them, all that good stuff. But it's still pretty good. Nah, I'll worry about it. We'll come back to that one. I didn't know what that one actually was. So okay. Anyway, so and then it's similar to pyramid, just like it's kind of like prism is to cylinder, right? As pyramid is to cone, right? So we have a cone here. I'm gonna make a cone, but if we want to find the surface area of a cone, again, it's the same formula. I'm going to use the same thing. The only difference is that a cone is just a a pyramid with a circle base. That's all that it is. So we still have the slant height. We still have what would be the equivalent of the actual sort of just height. We have a circle, so we have a radius. We know that those form a right angle. We can do things with that. But it's still the same formula. It's 1/2 PL plus B. In that's the same thing. That's the same thing. Oops, sorry. I meant that the slant height and the area of the base are the same thing. Again, the only difference is that the area, no matter what, is going to be pi r squared because it's always a circle. The perimeter is actually circumference because there's no perimeter of a circle. And let's see. Got a question. In the formula, it's the slant height. Yeah, the formula is the slant height. You sometimes are given the height, you got to find the slant height. You need the slant height for the surface area formula, for sure. Does the normal height form a 90? Yes, normal height would form a 90. Again, basically, if you drop the height down to the middle, to the center, either the center of the polygon or the center of the circle, depending on if it's cone or if it's pyramid or cylinder. Hang on a sec. And so we are... yeah, so depending on what you have, right? So a lot of times you might be given the height and the radius. You can find the slant height, Pythagorean theorem, stuff like that. And then circumference, sorry. So the perimeter is the circumference, which is 2 pi r. And then slant height is the same thing, right? It is the same thing from before. Okay, so we have, those are basically the formulas. There is one more. So maybe we looked at Mr. Greenhut's video from yesterday. It was a great video. Totally watched it all the way through. And so we're talking about sphere, right? Now the sphere is just, again, as much as it can be complex, some of the other ones, the surface area sphere comes down to 4 pi r squared. It's literally the equivalent of 4 circles, like 4 of the great circles of the sphere. And I'm saying great circle as in not like it's, great. Although that is pretty much a great circle right there. Okay. I don't know. I just wanted to use that one. But we still have radius, still have all that stuff. But that middle part, that sort of hemisphere, or that thing that splits it into two hemispheres, is going to be your great circle. It comes down to 4 circles. Like it's 4, the equivalent of 4 of those circles is going to be the surface area of your sphere. And again, it's nice because you only need one thing. It's just the radius. That's all you need. So if you give it the diameter, you can find the radius. If you're given maybe the area of that circle, then you can find the radius. But basically, you got to find the radius. We're supposed to use. So we got the radius is the apothem, correct. Let me touch on that one in a second. How do you know the difference between the slant height and the normal height? Well, okay, so I'll jump back to that as well once I get there. We're supposed to use the SOHCAHTOA sometimes. Yeah, okay, so I'll answer all those questions now that I actually, to be honest, I did all the formulas, right? So there are all 3 formulas. Okay, so let's go answer some of these questions here. Feel free. Also, there is a discussion board that we posted on Schoology. If you have questions, if you think of questions, I'll touch on those. I didn't. It was kind of new. I didn't actually see any today. But if there are any, we'll basically reply what video we're answering. So either Mr. Greenhut or I will be bouncing back and forth answering them. But anyway, as far as questions go, okay. So let's go back up to how can I tell the difference between the height and the slant height? Okay, sort of depends on the pyramid. Let me actually get maybe I can get a better illustration of a pyramid in here to look here. Okay. Here's one. Let's do this one right here. All right. So if I'm looking at this, right? I mean the height here, right, is just it's the distance from like this point down to here. And again, if I drop this straight down, then it will form a right angle. Again, I could label it as like, over here if I really wanted to. Like I could call that the height or that the height, but it's basically saying like it's a vertical height. If the base of it is flat on the ground, it's vertical. It's a vertical height. If it was flipped or something, the height is still the distance from that vertex, right? So in other words, even if I took this, and apparently it's all one thing, which doesn't help my case here. But even if it was like, let's do a cone then, it's easier to draw. But even if I sort of flipped it to the side like this, the height is still from this vertex right angle to that actual base, right? That would be my height. Okay, slant height is what you need for your formula, and the slant height is, it's even an L because it's the lateral height. It's the height of one of the lateral faces. In this case right here, there are 6 lateral faces because it's a hexagonal pyramid. So like this is one of the lateral faces, and it's a triangle. The height of a triangle is just, well, if I sort of redrew this triangle, we would know the height of this triangle would just be like this, or one of the heights of the triangle with this base would be there. So like that would be the equivalent of this. So it's a slanted height. It's the height of the lateral face. That's what it is, right? That's what it comes down to. Are we supposed to use SOHCAHTOA sometimes? Yeah, you're going to have to use SOHCAHTOA sometimes. Especially in the case of if the base is, in this case, which totally rhymed. I know, right? Seriously, tone it back. Okay. If the base was in this case, a hexagon, right? We'd end up using, to find the area of it, we probably have to use our formula for regular polygon. But that's going to include a special right triangle in this case, because it's going to be 30, 60, 90. But in the case of something that maybe like a pentagon, I might have that actually somewhere in here. No. Just try to, maybe I do. Yeah, there it is. Okay, so if I have, like, for instance, if it was a pentagonal pyramid in here, then like the shape of this base, assuming it was a regular pentagon, the shape of that base, we would have to find it using 1/2, like the area of it using 1/2 AP. But the apothem, to find that, if you knew the perimeter, you're going to pretty much have to use SOHCAHTOA. Yeah. Again, it's just like the area of a regular polygon. We did that last chapter. That's sort of now just brought into this chapter now. Okay, the radius is the apothem. Not really. in the, like if I have this hexagonal pyramid here, like the apothem would be like the apothem of the base, and it would basically be that blue line right there with the right angle, or it could be like going to, that was terrible, going to like this, the middle of that side with the right angle. Again, that was pretty terrible, but again, the apothem of that is going to be like the bottom. It's not necessarily the radius, because the radius would go to the actual edge, like it would go from the center to one of the actual vertices. But the height, the apothem, and the slant height will form make a right triangle in there. Right, so there's some areas that we want to. If you see a right triangle, we know we can do trig, we can do special right triangles, we can do all that stuff to find. All right, so we're about we're more than halfway in. So let's just do maybe a couple of examples that use a bunch of these things, because some of the other things that we talked about were composite figures, just taking more than one of these figures and sort of merging them together. All right, so if we look there and we look at, I don't know, we could do, like, these are all relatively straightforward ones. I mean, maybe we can start with one of these where this right here, I'd identify this as a triangular prism, right? Where, I can't see that other side. I know it is. I know it's there. It's a triangular prism. So if I want to try to find the surface area of this, okay, let me make this a little smaller. So the surface area of this, we would really, let's use a different pen. No, I don't like the smaller one. Okay, so we'd start with the formula. Always start with the formula. So we have the surface area of any prism, pH plus 2b. Okay, we know what, these are the sort of our shopping list here. We need P, we need H, and we need B. This is how I always set it up. If Mr. Greenhut sets it up differently and it works for you, by all means. But we need the perimeter. That's the perimeter of the base. So this is one that people miss a lot, where they look at this and they say, what shape is the base? And they're thinking, oh, that shape of the base, the thing is that's going to be like a rectangle back there. But remember, that's not the base. The base is, no, I didn't mean that at all. The base, right, is going to be, I'm looking at the screen weird. Okay, but the base is going to be what shape there are two of. To make it a prism, there are two bases, and they are the parallel figures that are congruent. So in this case, it's actually the triangles are the bases. Again, I'm just going to sort of say, yeah, that right there is the base, and then of course there's one that we can't really see all of, but like those would be our bases. So the perimeter of the base is going to be 37, 37, okay, it looks like an isosceles triangle, that might be helpful. 37, 37, and then something along the bottom. I definitely define that. I can't actually find that yet, so I need to, like, if I can do a little side project here to find this perimeter, I'm gonna have to, right? So we got 37, we got 37, and then we actually, good news is we have a 35 down here. And then it's a right triangle. So we can actually look at this and say, okay, that looks like a Pythagorean theorem situation for me, where I can be like, where I can find this value right here. Because we have the Pythagorean theorem. So like x squared plus 35 squared equals 37 squared. Right, okay, pulled up over here. But basically, 35 squared, you know what, 37 squared. Okay, so that actually ends up just being like 37 squared minus 35 squared is just 144. Oops. And so good news is that means x is 12. So that means this value right here is just 12, which means that's 12, which means that whole side is just 24. So actually the perimeter of our triangle here, what? No. I don't know. Don't know what happened. All right, but the perimeter of our actual base, which is our triangle, right? I don't know why I was doing that. Is just going to be our 37 plus 37 plus 24, right? I'm doing that off screen, but it's 98. So 98 is going to be our perimeter there. So again, that took a lot of work to do just to find the perimeter of this triangle. I had to do Pythagorean theorem, recognize it was an isosceles triangle, so it's split it in half. So if I found x, I could find the other side and then deal with Pythagorean theorem. But that was fine. Okay, the height is a little bit easier in that it's the distance between base. It's from base to base, right? It's from base to base, and from base to base is just 32. right? And again, I know someone's going to put 35 there because they're going to say, oh, the height of the triangle, height of the prism, same thing. But they're not. The height of the prism is how long the prism is from base to base. The height of the triangle is the height of the base is like a whole different thing. It's the height of the individual shape that is the base. So be careful. And then the area of the base. Well, again, the good news is I know the area of the base is going to be a triangle. So it's 1/2 base times height. I actually know the base and the height already. The height of the triangle is 35. The base is this whole side, which I already said was the whole thing was 24. Right? I already figured that out from before. So I can just actually plug those in to find out what I'm looking at here. So 1/2 for 24 times 35, right? Right, so 12 times 35 is what we are looking at. So 12 times 35. And then half of that, right? So 12 times 30. No, actually it is. It's the area of this base is 420. And so we have all the information we need now. We plug it in. We're going to say, all right, or actually I can do that a little lower here. So we know our surface area is, I'm just going to do black. Surface area is PH plus 2B. We know the perimeter was 98. We know our height was 32. And we know two of those bases together, we get 840, and then we can find 98 times 32 is 31, 36. And again, I'm just sort of doing calculations now, right? It just becomes a matter of calculating. And we can add those together. I'll add that. What is that? 840. I typed it in because I didn't click the calculator. Plus 840 plus 39 or 30. Come here. 39.76, and again. Centimeters, square centimeters. So that is our, so again, that was kind of a long, lengthy problem. And again, someone asked how we show our work. Yeah, you're going to do your work on paper. You should have work. You should do the work on paper. Like you should have, around this amount of work, right? Have a plan, show it, sketch out what you can. And then you're going to basically just take it. You're going to be taking pictures of it or scanning it or whatever you want to do to upload an image of it. So you're going to upload an image of all your work, whether that's 1, 2, 5 pages, take pictures of it, turn it in on Schoology like as a separate assignment. So you have the actual test itself. There you go. And then you're going to have the assignment. So there's going to be like an assignment that's going to be, hey, just turn in your work for the test that we just look at. And there's the actual test that you submit. And it's going to be based on answers and stuff. So make sense? I think it makes some sense. That's good. Can you leave? We still have to take the test. I know, right? Okay. Any other questions in there? I'm looking, I don't see any. Again, if we're good, I can do one more, maybe a composite figure shape and sort of maybe do one that would be, I think this one took up a lot of space simply because I'm trying to make it big enough for you guys to see, so it takes up a lot, but it wouldn't be that bad normally. So, all right, let's take a look. Maybe we can do, like I said, a composite figure one, maybe like this thing right here, little ice cream code situation. Okay. You should have our normal calculator is still in play. You need to use our normal TI 30X2S calculator, scientific calculator. SOHCAHTOA might be a thing. I mean, we've learned it before, so it could be on anything coming up, right? That's kind of what we have to think about. All right, so first thing we do on a composite figure one is we're going to need more than one formula. We're going to need more than one sort of thing, right? So what I would do is I'd sort of start by making a plan. Hang on one sec. And you can listen to me. This is not going to be worth it what I'm doing right now, but I just want you to know that I'm, where is it? Okay. All right, hold on. Okay, I said we should make a plan. Okay, I was trying to find the thing from the 18 when it's like, I love it when a plan comes together, but I couldn't find it. So I'll worry about that, okay? Maybe?
I love it when a plan comes together.
All right, maybe that wasn't so good. That wasn't what I was quite thinking of. Really wasn't worth it at all, but I thought, hey, I could use it for the next time I said I'm going to make a plan. Okay. Anyway, so surface area, right? Well, I need to find the surface area of this whole thing, right? So the whole idea is that I'm going to put total TSA for total surface area. It's going to be like surface area of some things sort of merged here. And so my plan is that it's going to be this top part, right? And this bottom part, basically. Those are the two shapes. One's a hemisphere, half sphere, and the other is going to be our cone, so we sort of go with that. And so we have our surface area of our sphere, but that's over 2. So I could write surface area of hemisphere or surface area of sphere divided by 2. Either way, it's still the same plan. Plus, and then here's where I have to think. Well, that right there is a cone, but I'm not having the base of a cone. So with a cone without a cone or pyramid without its base is just the lateral area of the pyramid. So I'm actually just going to write, I just need the lateral area of the cone. Can I change that? Cone. There we go. So there's my sort of plan, okay? And then from here, I'm going to be thinking, okay, I need to find the surface area of that sphere. Surface area of a sphere is 4 pi r squared. I know I'm going to be cutting it in half, so I actually look at that and be like, oh, that's just 2 pi r squared then. Oops, pi r squared. Right, because 4 divided by 2, so that's pretty nice. So all I need to do is find the radius. They give me the radius, so I'm just going to plug that in, and it's 2 times pi times the radius, which is 5 squared. 5 squared is 25 times 2, so we get 50 pi for the surface area of our, for this top part. So like this top part right here is 50 pi. I made sure I cut it in half, all that good stuff. All right, now we need to find the lateral area of our cone. Well, we know this, the lateral area of our cone is just the first part of the formula. It's just 1/2 PL. So the perimeter of the base is just the circumference, which is, in this case, is 2 pi r, which is just going to be 10 pi, right? Because the radius is 5, double it to 10 pi. It's going to be our P. And then we have the slant height. Well, that actually is going to be this. So this is where we need to actually think about what we're doing, because if I have trying to find the slant height in there, well, this is like the thing that's given is this value here. It's just written off to the side. It's the height. It's the height of this. So we have the radius, we have the height, we have the slant height. So in this case, it's nice because it's actually we know that that's 12, so it's 5, 12, 13. I know it's it's a 5, 12, 13 triple. If I didn't, I'd of course use Pythagorean theorem, but there it is. It's a 5, 12, 13 triple. I'm making sure I got that. So there it is down there. And now I pretty much have all of our stuff that we need, right? So we have 1/2 10 pi times 13. So that's 5 times 13. That's 65 pi. It's technically our lateral area, but I just put surface area there. So those are our two that we have to merge together, right? So together, right, we're going to be adding them together, and we can get, well, that's just 115 pi, and then whatever the units were, centimeters, so square centimeters. That is our sort of the total surface area of that figure. Again, you could just use surface area. I just use TSA just to differentiate it from the other formulas. So 115. So again, that one actually ended up being less work. It was 2 figures, but it ended up being less work than the other singular prism that we had. Again, it sort of just depends on what you have, what you need to find, what's there. So it's just, write the formulas out. The formula is the blueprint to solve something. It's the blueprint of what you need, right? So start with that and then go from there. Okay? We finished it. We reached the goal. All right. That was the Mario ending when you beat Mario 3. Okay. What do you think? Pretty good? All right. Hey, we almost kept 20 viewers the whole time. That was pretty good. I just, I might do a Zoom just to get some face-to-face going. I know if you have any individual questions once you're going through some of this stuff today, and again, there's that review packet, there's the actual homework pack that we have. There's plenty of stuff for you to look at. If you have actual questions, post in the discussion board. Mr. Greenhut will take care of it and extra help tonight, or I will the next day if he doesn't get to it. I might stop into that as well just to say hi. Anything else? Any other questions, comments, concerns? All right. All right, what else we got?
Life moves pretty fast. You don't stop and look around once in a while, you could miss it.
True story. Thanks, Ferris. All right. So I think that is it for me right now. Again, post the questions in the discussion board or at 4 o'clock today. There's scientific calculators on various devices. You need a scientific one, right? There's no way for me to look at what calculator you have, but I don't know. I'm going to use this drum thing as my outro, so